Hey everyone, this is Greg Gomez from Neal Analytics. I'm thrilled to have this opportunity to present to the group today on a game-changing technology that we've been fortunate to partner with Microsoft on, and I'm going to highlight a couple of very retail and consumer goods relevant use cases for this. I'm going to start by just giving a quick introduction into who Neal Analytics is, and then we'll jump into a couple examples of how this technology can be applied. First of all, Neal Analytics is a Microsoft partner focused on data and AI, and we're an end-to-end company in the sense that we help companies basically develop strategy and design around how they're going to map technology to business outcomes. We help companies stand up and accelerate their migration and modernization of their environment to support these initiatives. And then ultimately, we help bring the last mile services to operationalize and activate these solutions, embedding them in business processes, including deploying them at the edge, leveraging AI at the edge, as well as some of the IoT capabilities at the edge. We do focus primarily on the retail and CPG markets, although we do work as well in manufacturing and a few other industries as well. And so you can see we've been recognized multiple times in the Partner of the Year category with Microsoft for the work that we've done in this particular space. These are examples of some of the customers that we've worked with in retail and CPG, and this represents a variety of business transformation maturity across the brands that you see here. And one of the important aspects around Neal Analytics is we like to say we meet customers where they're at, and a big part of what we do is help customers advance and accelerate their transformation journeys while reducing risk and improving the outcomes. So for this discussion today, what I wanted to start with is just a level set on what do we mean when we talk about intelligent automation, and how does that differ from automation as we hear it often in the world today from a technology perspective? Then I'll introduce Microsoft Project Bonsai. This is the exciting technology that I was referring to at the beginning that's enabling companies to build and deploy autonomous or systems or intelligent automation systems. And then I'll talk about two specific applications of this technology. One is more on the production side and probably more relevant to consumer goods companies in terms of production yield optimization. And the second is one that sort of impacts everybody and is very relevant today in the current environment, which is how Bonsai can be applied to help optimize supply chains. And then we should have a little bit of time at the end for question and answer. So as I said, starting with sort of the concept here, when we talk about intelligent automation, how is this different from automation? A lot of us are familiar with the term automation. It's typically referenced along with the RPA and BPA, or robotic process optimization or business process optimization. But when we hear the terms automation, typically what we're talking about are think of them as bots or robots that perform simple automation, and they tend to be systematic and repetitive tasks that are often very much rules-based and very easy to define in terms of rules. And again, they're typically focused on performing routine tasks. The instruction set is something that can be very well defined, and the goal for these automation scenarios is to improve efficiency and reduce error rates, which obviously has a benefit to the business. When we talk about intelligent automation, there's a bit of a nuanced difference here. What we're talking about now is more advanced automation capabilities, where we're combining elements of RPA, but we're also bringing in AI in the form of deep reinforcement learning and neural networks. We're bringing in simulators, sometimes digital twins, and what we call machine teaching, where we're teaching the AI how to more or less act like a human. Intelligent automation automates and optimizes very complex processes. The ability to manage multiple goals, including even dynamically changing or competing goals, is a core capability in intelligent automation. And as you can imagine, again, that's very relevant today, where we see situations where demand patterns are changing daily. And then, the last key aspect of intelligent automation is the ability to think and learn, adapt to changing conditions. As I said, a key element of intelligent automation is that ability to recognize and manage dynamically changing environments. A byproduct of this as well is the ability to improve efficiency significantly, and even enable new capabilities that didn't exist before. So with that, let me introduce Microsoft's Project Bonsai. Bonsai is currently sits within Microsoft Research, and it came out of an acquisition of the company Bonsai a couple of years ago. What Bonsai represents is a platform for the development of intelligent automation solutions, and or better known as autonomous systems. What this platform provides is an end-to-end tool set that allows me to teach a brain, as we call it, which is the AI component, using simulators and other sources of data, including IoT. And so that I have a training engine, I have a coding engine called Inkling, and the ability to bring the simulator data into the environment. And it's very much, if you're familiar with the concept around self-driving cars, it's very much that same technology applied to complex processes. And so with a simulator, what I'm able to do is teach a brain what a process looks like. And this includes elements of what are the goals for the process, what are those goals, and what are the strategies required to achieve these goals. And as you can imagine, a big part of this is leveraging human subject matter expertise to teach the brain what those strategies are, what the actions are to accomplish those strategies, and again, what the goals are that we're ultimately trying to achieve. And so this process of teaching the brain, again, is sped up with the simulator. This allows us to throw millions of repetitive situations and circumstances at the brain in order to teach it. And ultimately, what you're doing with deep reinforcement learning is you're rewarding the brain for making the right decisions, and not rewarding it for making ineffective or incorrect decisions. What this does is help the brain continually improve how it manages its response to differing signals and inputs. And so part of the simulation is to teach it the process, to give it a large sample size of data to learn off of, and also give it fringe or curveballs, if you will, anomalies and so on, that the brain needs to be able to react to. And one of the beauties of working with this technology is you don't necessarily have to have all of the data for every circumstance and situation that the brain might encounter, because again, the brain is focused on accomplishing goals, not necessarily predicting or learning from what's happened in the past. It's learning from what it needs to do to accomplish those goals. Once that brain has been trained, I can export it and I can deploy it in a variety of different form factors, including on-prem, in the cloud, or at the edge. And you'll see an example in a minute where deploying a brain at the edge makes perfect sense, because we're talking about a manufacturing environment where we're controlling plant equipment and need to have that low latency immediacy in terms of allowing the brain to assess product quality and make changes to the production process to keep product within spec. And when we think about where a Bonsai brain outperforms current approaches, be those human or even machine learning, it can be categorized in a few different ways. One is if I have an extremely robust set of requirements, and I've got many different settings that need to work together and work well under a variety of different conditions, those are ideal scenarios for a Bonsai brain. Another one is, as I said earlier, where I've got multiple or even changing or even competing optimization goals. Bonsai brains excel at managing all those goals in parallel and optimizing around the different parameters that impact those goals. And lastly, is situations where human beings and operators are just overwhelmed. There's too many variables, there's too many changing conditions, and they need help making decisions across all these different scenarios. These are scenarios that are perfectly suited for a bonsai brain to excel and achieve the desired outcomes. So as I said, the first example I want to share is how a bonsai brain has been applied to a very common scenario in consumer goods, which is production yield optimization. Ultimately, when we talk about production yield optimization, we're talking about maximizing the production or throughput while managing and maintaining quality of the product. And the example I'm going to share here is a project that we've been working on with a global snack food manufacturer, where they were looking at how can we improve the throughput of our product while maintaining quality in a situation where I've got a number of different variables that change over time. And human currently, or the status quo was human operators have to periodically visually inspect the product to ensure that it's within spec. And this includes physically measuring the product for a number of different dimensions to ensure that it's within specification. And then based on those measurements, know and understand which elements of the production process need to be adjusted in order to bring the product back within spec. And so another way of looking at this is if we take this process, which is again quite common in the manufacturing of consumer products, where it's based on an extruder, and an extruder is essentially responsible for combining different ingredients together, compacting those ingredients, forming, shaping, cutting, heating, and so on, all as it's prepared for baking and finishing to be produced and put into bags and shipped to store shelves. And as you can imagine, with all these different elements coming together in this process, there's a lot of different things that impact the quality, in this case, the shape overall of the product. So what we were able to do with the bonsai brain is actually take the data from the extruder, as well as from a simulator that we built that allowed us to simulate a variety of different environments and dynamic conditions, and teach a brain how this process works, and teach a brain what the goals are in terms of the specifications and the speed of production, as well as teach a brain how to react to a variety of different changing conditions. Once the brain was taught, we were able to connect it directly to the production process and actually allow it to control a number of these variables. So once the brain is in place and it's been taught through the simulator how to perform its job, we're able to use computer vision running at the edge to continually monitor the product as it's coming off the production line. And we're able to use the computer vision to provide the inputs on whether or not the product is within spec, and have that be a continuous process. The brain is able to process those images, and based on the measurements that's provided by the computer vision AI, it now knows which elements or which variables of the production process need to be adjusted and in which direction. So based on those visual measurements coming from our computer vision running at the edge, the brain might know that it needs to adjust the torque in the extruder, or it might need to adjust the oven temperature, or it may need more water, and so on. But it can do all this dynamically and continuously and automatically, ultimately controlling the process directly as it evaluates the images of computer quality. And again, this overall process is brought together by a combination of computer vision and AI running at the edge, a simulator that's used to teach the brain, and then a brain itself that's operationalized at the edge so that it can continuously receive these inputs from the computer vision and then directly control the process controllers that are part of the extruder process. And it's really interesting to see the data coming off this when we actually put the brain into action, what we call auto mode, which means the AI brain is controlling the production process. And what you see on this graphic here is several different trial runs with the brain operating the production process. And these are different. These are three different quality metrics that are being measured to see if the product is within spec. And what you see is each time we threw curveballs at the brain, you might see one or more of the variables go out of spec, and that's where you see the red dots. But then you also see how quickly the brain is able to adjust and bring the product back in spec. And ultimately, what you can see is that across the time period of this test, the amount of time within specification is quite high across these variables. And the goal is to, equal or better what a human being can do in this process with again, the business benefit at the end of the day being I can produce more product with less waste, and of course, all the ramifications that come from achieving those goals. So that's the example around production yield optimization. I'll switch gears now and talk about another example, how this same technology can be applied to a complex business process. So moving out of a manufacturing and production scenario in a plant and more into a very complex process that spans a number of different business functions, which is typical in supply chain. And now what we're talking about in the supply chain example is, again, managing multiple goals, the ability to optimize dynamically as we see changes in demand patterns and inventory levels and so on, and the need for continuous learning and improvement, because again, we're talking about a very dynamic environment, and as variables change and as the environment changes, the brain needs to be able to continuously improve how it reacts to and optimizes around those changes. So as we all know, supply chains are very complex. When you think about a supply chain from end to end, each of the typical, aspects of supply chain also involves many different processes, each of which has its sort of own optimization opportunity around it. And one of the beauties of the Bonsai brain is that you can build brains to optimize specific processes like optimizing inventory levels, but you can network multiple brains together to create more of an end-to-end system where, as I'm optimizing for certain, again, goals and objectives, I'm able to do that across a variety of different optimization scenarios, so that even if I'm focused on fulfillment and on-shelf availability, multiple brains can be pulled together to bring other aspects of supply chain into that optimization scenario. So I might be looking at optimizing inventory. I might be looking at optimizing my production scheduling, all as I'm managing on-shelf availability and fulfillment. And so this is where brains become really powerful in the context of a very complex business process like supply chains. And again, the way we accomplish this is really the combination of simulation and machine teaching. So when we think about supply chains, many organizations use supply chain simulation tools to help them design their supply chain process, to model that process for their business, and to optimize. In other words, human beings will do what if analysis on a variety of different settings and scenarios in order to determine how they should manage and set up that process within their business. But when you combine this capability to model supply chain processes, perform what if scenarios, and evaluate and optimize, when you combine that with the Bonsai brain, what you're able to do is export these models directly into the brain to teach the brain what that process looks like, what the goals are, and what the actions it should take are to achieve those goals. And that gives you a head start on putting a brain in place that can start to manage all these different complex business processes and, again, optimize them. But the beauty of this is, as the brain begins to learn and understand these processes and what it takes to optimize them, it can provide feedback to the simulator that allows us to have those optimizations and those improvements embedded in our model. So what you have now is a model that is enhanced by the AI brain. And so the human beings start the process, the brain learns and improves the process, And you have this continuous feedback loop across the supply chain that is continually learning and continually improving and continue to optimize as you go through it. One example of this is, again, I mentioned earlier, inventory optimization. And again, what we're talking about is optimizing inventory replenishment so that we can have consistent and stable stocking levels, avoiding on-shelf availability issues like stockouts, which ultimately translate into lost sales. And the challenge for many companies, especially grocers, as they're dealing with varying demand drivers around products in the grocery, and also the growth in omni-channel fulfillment or omni-channel ordering for products in the grocery store, is you have this many-to-many relationship. You've got distribution centers, you've got local supply locations, you've got situations now where stores are becoming fulfillment centers. And how do you manage replenishment decisions across all these different levels and relationships? And most of the optimization methods that are in use today are more linear and again, not built to handle the rapidly changing dynamics that we see on these complex scenarios. The other thing is forecast and demand forecasting, inventory and sales forecasting are all key elements of understanding inventory replenishment and creating predictable stock levels. But forecast inaccuracies can throw a big kink in the chain of trying to keep those stock levels where they should be. So the ability to take this whole process and decompose it into a bunch of different combinations across products and distribution centers, and then use a simulator to teach a brain how to manage these processes and do so with many different combinations and changing profiles, allows us to create a model that can be put into place that sees across all these different relationships and continually optimizes and gives us the opportunity to improve and optimize inventory levels to the likes of which can't be accomplished with traditional approaches. Lastly, you can take things, take the IoT story and augment the brain and augment these processes with things like computer vision at the edge. So one of the projects we're working on with a national pharmacy retailer is the ability to use computer vision running at the edge to identify stockouts in real time on the shelf. So yes, we have our simulator, and yes, we have our brain, but if we can provide additional input into this process, into real-time stockout conditions that are being recognized by computer vision running at the edge, we can again provide the brain with the opportunity to optimize around what's happening in real time in the world, learn from those conditions, and continually improve the process to manage inventory levels at the optimum levels, including when there are dynamically changing conditions that perhaps haven't even been seen before. Finally, we'll talk a little bit about how we get these projects off the ground. What does it take to successfully implement a bonsai brain? Well, it's important to understand that there's a very structured process for this, and that, as I said earlier, subject matter expertise is key. We want to leverage the folks in the organization, and it's critical too, who know these processes, or if we're talking about production in a manufacturing setting, who know the dynamic conditions, who know how to assess quality for a product. And the beauty of the bonsai platform is that it's geared towards taking that subject matter expertise and putting it into the brain, and that's primarily what the platform is designed to accomplish. We want to extract away the data science, if you will, of deep reinforcement learning and focus on the subject matter expertise, the goals and the strategies that are part of that process, and make it easy for us to take that subject matter expertise and migrate it into the brain. And then from the other aspect of how do you take this brain now and operationalize it to actually impact these business processes, that's where Neal Analytics brings in sort of the integration capability. There may be the need to support the brain with additional ML and AI capabilities like the ones I shared in the examples here, either building a custom simulator or incorporating computer vision at the edge to provide inputs to the brain. The ability to help take that customer process and map it to a brain, and the ability to deploy these capabilities at the edge or wherever they may need to be deployed is an important part of the process when we talk about implementing a bonsai brain. So that wraps up what I intended to share around autonomous systems in retail and consumer goods. If this is something that you find interesting, we'd love to help you understand more about how it might be applied in your environment. And I encourage you to reach out to me or visit us on nealanalytics.com.